If you want to implement Towers of Hanoi recursively in a programming language and you have 3 stacks like source, intermediate, and destination, and your task is to shift those parts from source to destination with the constraints of Towers of Hanoi, which are that you can only move one part at a time and only push smaller ones onto bigger ones, you have to figure out where the recursion is first. So your task is, as I said, to move all 4 parts, in this case from source to destination. How can you achieve it if you are only able to move one part at each time? Well, you have to somehow reach the bottom part, so you have to move those top parts to intermediate, such that if you are in this state, you can move the lowest part or the biggest part from source to destination, because then you are done with the biggest part and you only have to focus on shifting those remaining parts from intermediate to destination. And that's it. This is where the recursion lies. You have your whole stack. How do you reach the bottom part? Well, you have to move the whole stack except the lowest one, so the top 3 ones from source to intermediate, not to destination, like this. This is a recursive call for the stack size -1, and after that you want to do a operation of shifting this one part, the biggest part, from source to destination, and after that have again a sub-problem of Towers of Hanoi, because now you have again the problem of shifting a stack, in this case those 3 parts from intermediate to destination. Back again to the start. Here on the left side you can see the state in which we are starting. So we have a source with 4, 3, 2, 1. In Python you can just use a list. In other languages you would like to use a stack. In Python the start of the list is the bottom and the end of the list is the top of the stack. You want a function that is, for example, called Hanoi, and you're passing the current count of parts you have on the stack, the source, the intermediate, and the destination. So just those things you have defined. And now we begin to implement Hanoi by facing what the first recursion was. And the first recursion was to reach the lowest part, we somehow have to move the upper parts from source to intermediate. So we have a sub-problem of moving those to intermediate, such that we can solve our main problem of shifting all those parts to destination, because we have to reach the lowest parts. So we know we can call Hanoi with n-1 because we just want to use all except the lowest one. And where do we start with this stack? Well, we are in source. We want to go to intermediate. So our intermediate of the main problem now acts as our new destination, and we can use the destination of the main problem as the intermediate in our sub-problem, so in our recursion. This means we can call Hanoi with source, and now we just switch destination and intermediate. Right now, our definition would start with this state, go into this line, call Hanoi with those parts. Inside this Hanoi function, we would do the same. So we're calling it with those 2 parts. And after that, another recursion later, we would call it with only the top one. Well, what do we have to do if you only have one part? We can just move it to our destination, to our current destination of the recursion. So we know in the deepest recursion where fn is equals to 1, we can just pop the remaining top part. So we can specify our part as source.pop, and we want to push it to our current destination. And we can do this by saying destination.append. Append acts like a push in Python, and we put the parts into it. Now this whole thing also acts as the recursion anchor. We can return back to the whole picture. After this call, where we shifted the top ones to intermediate, we can move the biggest part from source to destination. So we just have to go to the next line and do part is equals source.pop destination append part. Those two lines are doing exactly this operation. And if we have done this, we know we have still the remaining 3 parts. So again, n-1 parts if our starting size was 4, and we want to move them from intermediate to destination. So our intermediate acts as the new source and our destination acts as the new destination, and we can use our source as the new intermediate. So we can call Hanoi with n-1 as well, intermediate as the current source, source as the current intermediate, and destination as our destination. And after that, we are done with the function and we can return. So this line is actually doing the rest of the algorithm, and we have successfully shifted all parts to destination with the constraints that were given. If you are working with recursion, you always have to imagine the recursion as a black box, and you just have to figure out where the recursion appears. So the recursion was, if I want to shift the whole stack from source to destination, I can also move a smaller stack from source to intermediate. That is the first recursion call. Then I can do an operation like here in line 9 and 10. And after that, I can do the other recursion call of shifting those remaining parts to destination as well. If we now execute our code, we can see that we successfully moved the parts from source to destination and the order is remaining.